Okay, good morning, Honors Pre-Calc. This is going to be a video to finish up the notes from section 3.1. So I want to just start by talking one more time about E. E is just a number. It's about 2.718. Um, don't be intimidated by that. It's just a number, just like pi. So if you're asked to graph, if they give you y equals e to the x and they're asking you to graph it, um, just, you can make an XY table just like we did before. Um, just know that e to the power of 0 is 1, just like anything to the power of 0 is 1. E to the first, that's just going to be about 2.718. That's a point right there. Then you can type in your calculator e to the second. E to the first, e to the negative first, that would be 1 over e. So that's 1 divided by 2.71. You can figure that out in your calculator. So it's still graphable, it's still doable. And the graph actually is this red one right here. I have 2 to the x graphed and I have 3 to the x graphed. And you can see that the red one, e to the x, is closer to the 3 to the x because 2.718 is closer to 3 than it is to 2. So even though you have problems with E, they're okay. You can still do them. Okay, this is something that we haven't talked about yet. So this is your general form of an exponential function. We are going to find an equation for an exponential function that contains these 2 points, 0, 4, and 2, 1. So let's just start by looking at this point right here. Instead of the f of x, I can write it as a y. We can plug a 0 in for x and we could put a 4 in for y. So now what's going to happen? Well, b to the 0 is 1. So right now we know that 1a is 4. We got that figured out. So I'm going to switch colors. So now what we know is that a is 4, and we still have to figure out what b is. So now I'm going to use this point. So I'm going to plug in a 1 for y, and I'm going to plug in a 2 for x, and we're going to figure out what b equals. So I would start by dividing by 4. So 1/4 equals b squared. Got to take the positive and the negative square root of 1/4 to get b alone. Remember, you can separate your square roots. So it looks like we're going to get plus or minus 1/2 for b. So that means that we can choose either one of these values for b. So my final answer could be y equals 4, because that's what a was, and then 1/2 to the x power. Or I could do y equals 4 times negative 1/2 to the x power. One would be growth, one would be decay, but they would still go through these same 2 points. And if you're a little unsure of that, just graph them in your calculator and you'll see that they go through the point 0.04 and the point 0.21. This one, we will talk more about probably on Monday, but I'll just kind of get you started on it. It's the same kind of problem. There's just a little twist though. So let's say we start with this point right here. We would put a 9 in for y. I don't know what a is, I don't know what b is, but I'm going to put a 2 in for x. So we run into a problem right now because I have 2 letters, 2 unknowns, and only one equation. So I can't solve that. So then what you could do is you could say, well, then I'll try the other point. So let's try this point right here. So I would put in an 81/4 in for y. I don't know a, I don't know b, and I'm going to put a 4 in for x. But again, I get stuck because I have 2 unknowns. So what do you do when you have two equations and two unknowns? Is you can solve like using substitution. So um, maybe what I would do is try to get this a all by itself. So I could do that if I divided by b squared. So I've isolated the a. Now I could plug in 9 divided by b squared in for a into this equation right here. So then I would have 81 over 4 equals 9 over b squared times b to the fourth. Well, it's going to work out because I can cancel 2 b's from the bottom and 2 from the top. So now I would have 9b squared. And then we can keep solving from there. So what I could do is I could cross multiply. So I could do 4 times 9. So 36b squared equals 81 times 1. And then we could divide 81 by 36. And then I would have to take, I need some more room. I would have to take the plus or minus square root of 81 over 36. And again, you can separate those. So I would have the square root of 81 on top and the square root of 36 on the bottom, which works out nicely because then I would get 9/6, which reduces. So 3 goes into both of those, so plus or minus 3/2 for b. So we got b figured out, but what we still don't know is a. So we can plug this value of b right here, and then we can get our value of a. So 9 divided by either positive or negative 3/2 squared is going to turn out to be the same thing. So 9 over 4 will equal a. If you multiply by the reciprocal, so if you do 9 times 4 over 9, looks like you're going to get 4 for a. So then we can write our equation. Y equals 4, and then b can either be positive 3/2 or it could be negative 3/2 to the x. So either one of those would be okay. So this one was a little bit more intense. We had to use substitution. The previous problem was way easier because I had this point right here. Anytime you have 0 comma a number, it's going to be so much easier because b to 0 is 1. You're going to automatically get a right away. Okay, moving on. The next things that you're going to see in the homework are exponential growth and exponential decay. These are our two basic formulas for growth and decay. A is the initial amount. So whatever amount you start with. R is the rate at which you are increasing or decreasing, growing or decaying. Just be careful if they tell you that the rate is 25%, you're going to plug in 0.25. So watch out for that. If they tell you it's 3%, you're going to plug in 0.03. That's a place people tend to make mistakes. And then T stands for time. So here's an example. After 2 years, the value of a car that costs $20,000 is modeled by this equation right here. What's the value of the car predicted to be in 10 years? So T is time, so all we have to do is plug a 10 in for T. So if you get your calculator out and you type it in, 20,000 times 3/4, gotta be in parentheses, just the 3/4 part in parentheses, to the 10th power, I'm getting $1,126.27. That's the bummer about cars is they depreciate in value right the second you start owning them. Um, Now the next question is asking by what percent is it depreciating each year? And you might be saying, well, it went from $20,000 down to about 1,000 in 10 years. That's got to be depreciating really fast. So that's what we're trying to figure out is how much is it? By what percent is it depreciating? So we're talking about decay. So this is our formula right here. R is the percent at which it's depreciating. You see how I'll use a different color. Everything in the parentheses matches everything in the parentheses here. So what we have right now is 1 minus R equals 3/4. Or if you prefer a decimal, 1 minus R equals 0.75. So that means that R has to be 0.25. So in this case, by what percent, it's depreciating at 25%, which is very high. I'd say I think 13% is what I saw last time I looked at like Kelley Blue Book. That's the thing you look up when you want to sell your car to figure out how much your car is worth now. Okay, next thing is compound interest. This you would use when you are compounding your interest. So it's growth, first of all. But this is when your interest is getting added on, not just once a year. It's getting added on, not added on, put on more than one time a year. N, right there and right there, that represents the number of times that you are compounding. Putting on interest. P still stands for initial amount. The correct word for it is principal. R is still the rate, and T is still the time. So here's an example. You deposit $2,000 into an account. So this is how much we're starting with. So that would be our principal, our initial amount. So that's P. So that's what we're depositing into an account that pays 8% interest. So that is our rate. But remember that we're going to plug it in as 0.08. We want to find the balance after 5 years. So that is going to go into our T for time. And we want to figure out how much, what our balance is if we're compounding quarterly. So if we're compounding quarterly, that's 4 times a year. So the letter we use for the number of times we're compounding is N. So this means, oops, I didn't want M. Hang on, I gotta delete or erase. N is 4. So now we're just gonna plug everything into our formula. So our initial amount was 2,000. We're gonna do 1 plus our rate of 0.08 divided by N, which is 4. All of that is going to get raised to the power of 4 times T, which was 5. Okay, so if you type that in your calculator, give me a second. It really helps if you do control divide whenever you're talking about sorry. It really helps when you do control divide whenever you are trying to do division. So like when I typed this in, I did control divide, so I had a nice fraction bar. Okay, so you get 2,971 and 89 cents. So this is the balance after 5 years. So I started with 2,000, now I'm up to almost 3,000. So this is just this $971.89. That's basically free money that you're getting for leaving this in an account. Okay, now let's look at if it's compounded monthly. Now what would n equal? The number of times you're compounding monthly, that'd be 12 times in a year. So it's basically the same setup except n is 12 this time. So 1 plus 0.08 divided by 12, and then up in the exponent it'll be 12 times, again the time is 5. So you can type that in your calculator and get your amount. Okay, next kind is continuous compounding. So you will see the word continuous in the problem. So this means that it's increasing without bound. It's just constantly happening, constantly growing. So P is still the initial amount. E is the number, E, 2.718, ... You've got an E button in your calculator that you should use. R is the rate and T is the time. Okay, so the approximate number of fruit flies in an experimental population after T hours is given by this equation right here. What was the initial population? Well, look, in our formula, the initial amount is kind of like the very first number in front of e to the power of everything. So here's our first number in front of e to the power of stuff. So our initial population is 20 fruit flies. Another way that you could have figured this out would be if you had plugged in a 0 for t, then e to the 0, all of this would be 0, e to the 0 is 1, and 1 times 20 is 20. After 72 hours, what is the population? So 72 hours is our time. So we would just do 20 times, well, I don't need those parentheses really, so I'm going to erase those. Okay, so 20 times e to the 0.03 times 72. Okay, so if you type that in your calculator, make sure that you know where your E button is. You can get it several different places. One place is where the pi button is. If you click on the pi button, it'll open up a little menu, and then you can select E. But again, there's other places you can get it. All right, so when I type this in, I gotta get down here. My cursor doesn't want to listen. Okay. It equals 173.42. So about, well, I guess we would round down 173 fruit flies. I'm running out of room, so I'm just going to say flies. Gross. So we started with 20 flies, and then 72 hours later, we're at 173 flies. Ick. Exponential decay is our next formula. In the formula, a sub 0 is your initial amount. T is time, and K is whatever the half-life is. So with exponential decay with half-life, if the half-life, so the half-life of radioactive strontium is 28 years, that means it takes 28 years for half of the stuff to go away, and then another 28 years for half of that to go away. So if 20 grams are present initially, that would be our A sub 0. Again, this was the half-life, so that would be K. If 20 grams are present initially, how much is going to be left in 14 years? That's time T. So we would do our initial amount of 20 times 1/2 to the power of 14 divided by 28. Okay, so if you type that in your calculator, again, control divide is very handy when you want to do fractions. Okay, I got 14.1421 grams. So we started with 20 grams. 14 years later, we still have 14 grams. We're going to ignore this. We don't have information to get that just yet. If you wanted to figure out after 20 years, it would be the exact same thing. You would just change your T to 20, but the half-life is still 28. So you could type that in your calculator and get that. Okay, that will be it for today. So you should be able to finish the 3.1 assignment. And this is technically 3.1 day 2. So when you get your assignment sheet, let's see if I can find our assignment sheet here. Okay, so there. You can see yesterday, this is what I told you that you could start working on. And then, because this was just the graphing of the parent function and shifting. And then 3.1, this is hang on. I have a better assignment sheet. I just need to find it. Well, the one that you're gonna get a hard copy of today, and the one that's posted online, these dates are different. So your homework then to finish up is these problems, and then there's an extra practice worksheet that you'll also be getting. So technically then both of these 3.1s would be something to get done over the weekend. That's why I said if you did this stuff last night, it would make your weekend go better. Okay, so work on the homework now for the rest of the class. Get as much done as you can, and I will see you on Monday.